Hello, my loves. Today we're going to be dividing decimals. So we're going to stick with the simple algorithm, and we'll move the decimal in the divisor to create a whole number and match the moves with the dividend. So remember, you don't want to divide when there's a decimal in the divisor. Just make your life easier and move that over. We're going to divide like we normally would with whole numbers. Now, if there's a decimal in that dividend, it just moves straight up. Here's our objective for today. We could use place value to divide decimals. What strategies can you use to place a decimal point in a product? Uh-oh, that was from yesterday. It's not supposed to be product. It's supposed to be, well, what's the answer for... What's the answer in a division problem? Quotient. It's a quotient. Fix that. Okay, what strategies can you use to place a decimal point in a quotient? Here are the lead measures for today. We've got a Math Antics video, IXL practice, and your teacher-assigned lessons, multiply decimals and divide decimals. And don't forget to get perfect attendance. You need 50 minutes math and 15 minutes reading. If you have 50 minutes math and only 40 minutes reading, then you will be absent for one day. If you have 1,000 minutes math and 5 minutes reading, that means you will be absent for all 5 days. You have to have 50 in each subject. That's really important. Okay, here we are at Math Antics.
That's gotta be hard, right? Well, multi-digit division is always a little hard, but luckily, decimals don't really make it very much harder. In fact, it's only when there's a decimal divisor that the procedure is a little different. If you just have a decimal dividend and the divisor is a whole number, it's really simple. That's because you can just do the long division procedure that we learned in the long division videos, and the decimal point doesn't affect it at all. You just need to make sure that you bring a copy of the decimal point up into the answer line when you're done. So, if you have the division problem, 12.64 divided by 4, you would follow the division procedure as if the decimal point was not even there, and you'd get 316 in the answer line. But then, you need to bring a copy of the decimal point straight up into the final answer, making it 3.16. That's all there is to it. If it's only the dividend that's a decimal number. But what if both the divisor and the dividend are decimals? Like, what if you have to divide 6.45 by 1.5? Well, the first step is don't panic. As you'll see, this isn't much harder. It turns out that there's a very simple trick that we can use to make it so our divisor is not a decimal number. We can just shift the decimal point in the divisor to the right until it's a whole number. But if we do that, then we also need to shift the decimal in the dividend the same amount to the right. So in this case, if we want to shift the decimal point in our divisor one place to the right so that it's 15, we can do that as long as we also shift the decimal point in the dividend by the same amount, which will turn it into 64.5. And here's the really cool part. If we do this new division problem, 64.5 divided by 15, we'll get exactly the same answer we would have if we did the problem 6.45 divided by 1.5. That only works because we shifted the decimal point in the divisor and the dividend by the same amount in the same direction. And you'll realize why that works if you remember equivalent fractions. Think about the fraction 1 over 2. That's the same as 1 divided by 2, right? Okay, but what if I multiplied both the top and bottom number by 10? That would give me 10 over 20, which is equivalent to 1 over 2. Even though it uses different top and bottom numbers, both represent the value 1/2. They're equivalent fractions. Well, that's what we did in our decimal division problem when we shifted the decimal point in both the divisor and the dividend by one place. We multiplied each number by 10. And since fractions and division are basically the same, we made equivalent division problems. But now, one of them has a whole number divisor. Pretty cool, huh? That means if we solve 64.5 divided by 15, we get the answer 4.3, which is exactly the same answer we would get if we did 6.45 divided by 1.5. And you can use that trick to avoid ever having to divide with the decimal divisor, even if the dividend is a whole number. For example, if you have the problem 148 divided by 1.6, you can shift the decimal in both the divisor and the dividend one place to the right. Remember, there's always a decimal point even in a whole number. It's just that when you shift it to the right, you need to put a 0 in the place that it shifts past. That gives you the equivalent division problem, 1,480 divided by 16. And since these division problems are equivalent, you'll get the same answer for both. All right, so that's how you can modify all the traditional arithmetic procedures to work with decimal numbers. They can be a little tricky at first, since there's a few extra steps that you have to keep track of when the numbers are decimals. But if you practice a lot and check your answers with a calculator, you'll get it. Remember, you can always re-watch this video if you need to, along with the other videos about multi-digit arithmetic. As always, thanks for watching Math Antics, and I'll see you next time. Learn more at mathantics.com.
Okay, so they didn't give us a lot of practice problems in that Math Antics video because they were explaining to us that long division with decimals is the same as long division with whole numbers. So if you want to review long division, go to the Math Antics long division with whole numbers video, and you'll get some good practice there. Let's start our practicing here with dividing by the powers of 10. Now this is just like we did with multiplication, and we were multiplying by the powers of 10. And remember, when you multiply, the numbers get bigger, right? So that decimal point moves to the right. But here, we're dividing. So the number is going to get smaller. For instance, 3,204 is going to get smaller by a factor of 100. So if I have 2 zeros there, that's a factor of 100, which is 10 times 10, which means I need to move it 2 places. And there's my decimal. I move it 1, and I move it 2. My answer is 32 4/100. That is my answer. Let me go ahead and type that in. 32.04. Fantastic. Let me clear. Okay, now go ahead and give this one a try. Pause the video, get your paper and pencil, and write this problem down. Okay, we're dividing by 10, so that means we are going to the left, because that's when the numbers get smaller on our number line. And we're dividing, so things are going to get smaller. There's my invisible decimal. There's always a decimal there. And I'm going to move it 1 place to the left. Did you get 94 5/10? Okay. Now this one is 7 divided by 10. Write it down on your paper. So I have my invisible decimal there after my whole number. And I'm dividing by 10. That's 1 place value, so it's going to move over 1. It'll be 0 7/10. Excellent. Okay, let's take a look at this problem. In this problem, we have 3 divided by 100. It is not 100 divided by 3. It is 3 divided by 100. Or, if you wanted to put it in a fraction form, 3 divided by 100. Now, how I remember that it's 3 divided by 100 is I think of this. This is my kitchen table that holds my 3 pizzas, or that's a pizza box. And there are 3 pizzas in those pizza boxes. And outside, around the table, I've got a party of 100 people. Can 100 people eat these 3 pizzas? Well, right now, those are whole pizzas, and they absolutely cannot eat those whole pizzas. So what do I need to do? I need to cut my pizzas up. And normally, when you have a pizza from the restaurant, Pizza Hut, Domino's, doesn't matter, they're usually going to cut your pizza into 8 slices. That's what they usually do. But when you're having a party, you can call them up and you could say, hey, can you double cut those? Or say, that would make 16. But here, even 16 slices is not going to be enough for 100 people. We have to think, how can we turn 3 pizzas into enough for 100 people? Okay? And the way we would do that with decimals is we would got our decimal right there, always a decimal at the end of a whole number. And now we're going to put a 0 there. So instead of talking about just whole pizzas, let's talk about tenths. If I were to cut each pizza into tenths, and tenths, I now have 10 tenths, 20 tenths, 30 tenths. Okay, oh, that's not 30 tenths. That was 3 tenths. 30 tenths looks like this. That's 30 tenths. And how I know it is when I say 10, 20, 30, 40, 50, 60, and I keep counting by tenths. If I get to 30 of them, it turns into like 300. And 300 would be the same as the whole number 3. So now let's think about 3 tenths. Is 3 tenths enough? If I have tenths, 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 that means I have 30 slices. Will 30 slices be enough for 100 people? No, it's not going to be enough. So what I'll do is, instead of talking about tenths, let's talk about hundredths. So now, if I'm cutting my pizza into hundredths, come on, clear, thank you. Get rid of you. If I'm cutting my pizza into hundredths, that means this pizza gets cut into 100 pieces, this gets cut into 100, and this gets cut into 100. So how many do I have? I have 100th, 200th, I have 300 slices now. I have 300 slices, but I still only have 3 pizzas. That's why my decimal is still right there. I still only have 3 pizzas, but now they're cut into hundredths. So every pizza is cut into tiny little pieces, tiny, like that big. But the question now is, if I have 300 slices and 100 people, that's a whole new problem, isn't it? 100 into 300. Now, you guys know that answer right away, don't you? 100 into 300. So how many hundreds are inside 300? Well, let's see. I'm going to focus 1 second on, let me get my yellow. Let's start over here. Let's start with a 3. Can 3 be divided into 100? Nope, not going to happen. So I'm going to move over to this place now. Now I have 30. Can 30 be divided by 100? Nope, can't happen. I'll put that as a red one. It can't happen. So my next step is to now go to the last place. Now I have a full number of 300. Can 300 be divided by 100? Yeah, and it's going to be 3. So the answer here is going to be 3. But notice how I have my 0s there, because 3 cannot be divided by 100, and 0 or 30 cannot be divided by 100. The same thing's going to happen here. Clear out all this mess. The same thing is going to happen here. Can 100 go into 3? No. Can 100 go into 30? No. Can 100 go into 300? Yes. And now bring that decimal point straight up. So your answer is 3/100ths, which makes sense because if we have 300 slices and we're sharing it with 100 people, each person is going to get 3 slices. But how much of the pizza will they get? If you get 3 slices out of that pizza, you have 3/100ths of a pizza. So the answer for 3 divided by 100 is 3/100ths. Okay? 0 and 3/100ths. Let me make sure. 3/10ths. Nope, that's 0/10ths and 3/100ths. There we go. You got it. All right, let's do this one. First things first, there's our invisible decimal. All right, can 5 be divided by 10? Nope, but you know what can be? 50. And I put that 0 after the decimal because it doesn't really make any difference. If I have this much money, it is exactly the same as this much money. It just says here, I have $5 all by itself. Here it says I have $5 and 0 dimes and 0 pennies. Well, I still had 0 dimes and 0 pennies there, but here I just put the placeholders, okay? It's the same thing as over here. So now, can 5 be divided by 10? No, it cannot. But can 50 be divided by 10? Sure. 5 times 10 is 50. And when I subtract, I've got a 0. And then that decimal needs to come straight up. So my answer is 0 and 5/10ths. Now what about this one? Can we divide 800 divided by 100? What would the answer be? Is it 800? Let's think about that. Oh, let me get my highlighter. Let's start here. Can 8 be divided by 100? Nope, it's going to be a 0. Can 80 be divided by 100? Nope, it's going to be a 0. Can 800 be divided by 100? Yes, it's going to be 8. The answer is 8. And how I can check it is, if I said 800 divided by 100, let's say I thought it was 800. How do I check my thinking? I check by doing the inverse operation. I check by multiplying these two, and then I should get the dividend. So let me multiply those two. 800 times 100. Nope, that's not correct, is it? So that's how I know 800's not the right answer. But we did it again step by step, and we said it was 8. So let me double check by multiplying these two together, and it should equal my, my dividend. So 100 times 8, it sure is, it's 800. Now that's how I know my answer is 008, or just 8. Okay. Pause the video and write this out on a piece of paper. Here's my decimal. And I know that 6 cannot be divided by 10, so I put a 0 there. But 60 can. That's going to be a 0, and that's going to be a 6. And there's my decimal. So what this says is 6 divided by 10, right? 6 divided by 10. 6 divided by 10. It's 6/10, isn't it? Well, guess what? This says 6/10. Perfect. 0 and 6/10. Okay, this is going to be the last one, and then we'll move over to the next. 10 can 10 go into 3? No. But can it go into 31? Yes. 3 times 10 is 30. And I have a 1. But when we are talking about decimals, we don't want to take this remainder. Well, first of all, we're never going to say remainder 1 anymore because that's back in 4th grade. We know in 3rd grade, or I'm sorry, we're not in 3rd grade either, 5th grade, we can interpret that remainder as a fraction. But they want the answer as a decimal. They want that answer as a decimal. So that 1/10 really looks like this, doesn't it? So how are we going to show that in this problem? Well, here's the very simple step-by-step algorithm. We've got a 1 there left over. I'm just going to add a 0 at the end and bring it down. And now I have 10. 1 times 10 is 10. And bring that decimal straight up. So the answer is 31 hundredths. And how I would want to check is I would do the inverse operation. The inverse operation is to multiply by 10. And we know that when you multiply by 10, you move it 1 to the right. Look at that. Or when you divide by 10, you move it 1 to the left, just like that. All right, so to review, when you multiply by a 10, you move it to the right 1 place. When you divide by 10, you move it to the left 1 place. Clear all drawings. Okay. I want to do this one here. All right, write your answer as a decimal, they're telling us. I have 648 divided by 5. So this looks like it's not even a decimal problem at all. It's just a regular division problem, isn't it? Let me write it over here because I think I'm going to need room, and I don't want to write all over that submit. 648 divided by 5. Okay, I'm going to start here. Pardon me. 6 divided by 5. Well, that's going to be 1, right? Because 1 times 5 is 5. And when I subtract, I have 1. I bring down that 4. I now have 14. So my new problem is 14 divided by 5. 5, 10, 15. Well, 15 went too high, so I'm going to have to stick with 10. And that would be 2 times 5. When I subtract, I have a 4. Bring down my 8. I now have 48. So my new dividend is 48 divided by 5. Well, I know my 5 times tables: 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. 50 went too high. I got to go back down to 45. So that would be 9. 9 times 5 is 45. And I have 3 left over. Now again, they want my answer as a decimal, so I can't say 3/5. But if I remember that there's actually a decimal there, and I'm going to put the decimal right up there too, because remember it just copies. I'm going to add a 0, and I'm going to put that 0 right down there. So now I have a new problem, 30 divided by 5. What is 30 divided by 5? It's 6, because 6 times 5 is 30. So my answer is 129 and 6/10. You know what? And that makes a lot of sense to me, because, let me get rid of you, and you, and you, and you, and you. If I had that remainder of 3 and 3/5, when we're talking about decimals, we can't have fifths. It has to be tenths, doesn't it? How could I turn 3/5 into tenths? Do you remember this? 5 times 2 and 3 times 2. 6/10. So that's where we got that 6/10. It's exactly the same as 3/5. They're equivalent fractions. Let me put my answer in, 129 and 6/10. And great job. 1 divided by 2. Now we know that looks like this, don't we? 1 divided by 2, 1/2. 1 divided by 2. So let me take my 1 and I'm going to divide it by 2. And my decimal is right here and it's going to come straight up. So let's start here. Can 1 be divided by 2? Nope. So it's going to be a 0. But now I can't have a remainder. So I'm going to add another 0. And now I have the number 10. What number times 2 equals 10? It's going to be 5. 5 times 2 is 10. So my answer is 5/10. Or you can always think, my decimals are always in tenths or in hundredths. 2 times 5 is 10, so 1 times 5 is 5. 5/10 is exactly the same as 1/2. You know what else is the same? 50 hundredths. So if you're talking about money, 50 cents is half of a dollar. 0.5. One more and then we'll move on. So we have 59 divided by 2. Now I can tell right away that there's going to be a remainder, because 59 is an odd number and 2 is an even number. So there's going to be a remainder left over. Let's do our math. 59 divided by 2. Now in the classroom, I tell you guys to cover up that 9 and focus on that 5, right? So let's do that. What number times 2 gets me close to 5 without going over? 2, 4, 6. 6 went too high, so I'm going to go back to 4. 2 times 2 is 4, and I've got 1 left over. Bring down my 9. Now I have a whole new problem. It now says 19 divided by 2. Well, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. 20 went too high. I got to go back down to 18. And that was 9. 9 times 2 is 18. And see, I told you there is a remainder. So back in 4th grade, remainder 1. Not going to cut it anymore. In the middle of 5th grade, we would say 29 and 1/2, which is great, but they want it as a decimal. And you guys know how to write half as a decimal, don't you? 0.5 is how you show half as a decimal. But how we can show it using the algorithm here, because we always want to show our thinking. You show that there's a decimal there, and then that decimal carries straight up. And we can add a 0, and we'll add a 0. And now we have, what number times 2 is 10? That's how that 5 got there. So the answer is 29 and 5/10. 29 and 5/10. Awesome. All right, we're going to do a couple problems here and then we'll be done. And then you can go on your own to do some iReady practice. And you can do IXL practice as well. Pardon me. Okay, give the exact answer written as a decimal. All right, so first thing I see is a decimal in the divisor, and we do not want that. So I'm going to move it over, and now my new decimal is right there. But since I moved that one over, this decimal has to be moved over as well, and that's going to become a 0. So that's where my new decimal is. So now I have a new problem that says 8 going into 260. That's my new problem. The decimal's at the end and the decimal's at the end. I know that I can't divide 2 times 8. So I know that could be like an invisible 0. But now I have 26. 8, let me do my hashtag helper. Let's see. 8 and 8 is 16. And 16 plus 8 is 24. And 24 plus 8 is 32. And 32 plus 8 is 40, right? So 26, I'm going to have to go down to 24. And that is 1, 2, 3. That's 3 times 8. And when I subtract, I have a 2, and I bring down a 0. 8 times what gets me close to 20? It's going to have to be 16. 8 times 2. And when I subtract 20 minus 16, 16, 17, 18, 19, 20, it's 4. So 32 with 4 left over. 32 remainder 4? No. 32 and 4/8? No, it said write as a decimal. Now you could think, oh, I know what 4/8 equals. 4/8 equals 1/2. And we know how to write 1/2 as a decimal. So it would be 32.5. Or you could continue with that algorithm. And we have that decimal here, right? Put a 0. Bring that 0 down. And remember, if there's a decimal there, there has to be 1 in the quotient. Now, what number times 8 is 40? Well, look, 1, 2, 3, 4, 5. That's where I got my half. 32 and 5/10. So you can always add those zeros after the decimal. Okay, we've got 1 divided by 8/10. Now again, we want to move that decimal over one place. And my decimal is there. You can't see it, but now we can see it. And I move it over one place, and now I have 10. So my new problem is 10, and there's that little decimal, divided by 8. Well, that's easy. That's going back to 3rd grade. 1 times 8 is 8. But now I have a remainder of 2. No remainders allowed. It has to be a decimal. So I add a 0 and bring it down. What number times 8 is 20? Well, it's going to have to be 2, and that'll be 16. And when I subtract, I get 4. Let me add another 0 and bring that down. Ooh, it's going to be 5 here because 5 times 8 is 40, and now I'm at 0. My answer is not 125. What is my answer? 1 and 25 hundredths. Remember that decimal has to come straight up. So 1 and 25 hundredths, 1.25 is my answer. Terrific. Okay, let's do this last one, and then you're on your own for some practice. This says 9 divided by 7.2. This says 9 divided by 7.2. Now, how do I know? Because I read from left to right my number sentence. 9 divided by 7.2. Or 9 pizzas divided among 7.2 people? Well, what? No, I am not going to cut my friends in half. So instead of trying to divide by 7.2, whoop, I just made myself super popular because now I have 72 friends. But since I moved that decimal, I have to move this one. And now my new problem is 90 divided by 72. Because what I did is I multiplied both of these by 10, multiplied you by 10, and multiplied you by 10. All right, let me get my problem going. 9 divided by, come on, there we go, 7.2. Oh, get rid of that 7. 72. Whew, I almost made a mistake there, didn't I? So it's 90, right? 90 divided by 72, because I moved this one and I moved this one. It's 90. Well, it's going to have to be 1, isn't it? And I need to subtract. Let me get a different color here, and let's show the subtraction. 0 minus 2, can't do it. So I go to my neighbor. Can I borrow a 10? And my neighbor says, sure, I've got 9 of them. Let me give you one of them. And my neighbor now has 8 10s, and they gave me a 10. 10 minus 2 is 8, and then 8 minus 7 is 1. So my new problem now says 18 divided by 72. Well, that's not going to work, is it? So I need to remember that there is a decimal right here at the end. So I'm going to add a 0, and then I'll bring that 0 down. So my new problem now says, bring that 0 back up before I forget. It now says 180 divided by 72. Now I don't know about you, but I don't know my 72 times tables. So I'm going to try 72 times 2. See what I get. 2 times 2 is 4, and 2 times 7 is 14. 144. Okay, let's try 73. Oh, 73. 72 times 3. 3 times 2 is 6, and 7 times 3 is 21. Ooh, it went way too high. So I'm going to stick with that 144. And that was times 2. And when I subtract, 0 minus 4, can't do it. Excuse me, neighbor, can I borrow a 10? And they say, yep. Now I have a 6, and I have a 3. I need to stick another 0 in there and bring another 0 down. Now I have 360. Now look what I have, because I did my math already. I know this one won't work. I know this one's too low. So I'm thinking maybe 4. You think 4 would work? Well, 4 times 2 is 8, so that won't work. I'm going to try 5. You know why I'm thinking 5? I keep doing that. Let me get that 72 back. The reason why I'm thinking 5 is there's a 0 here. And I know that 5 times 2 is 10. I'm going to try that one. 35, 36, it sure did work. So this is going to be a 5. 1.25, or 1 1/4, actually, because 25 cents is a quarter. Oh, get rid of that 360 now that I multiplied and I have 0 left over. So 9 divided by 7.2 is 1.25, or 1 and 25 hundredths. Awesome. All right. So I need you to go to finish your iReady lessons. Tomorrow is a review. We're going to review adding, subtracting, multiplying, dividing. Now your iReady lessons were to multiply and divide. So I'm going to make one of those Google form worksheets for you to practice adding and subtracting, because I want you to practice all of those things. And iReady is letting you practice multiply and divide. So I want you to practice add and subtract with that Google form, okay? And remember, that's for extra practice, and the answers are on the form so you can check your work. And make sure as you're checking, and if you're making mistakes, put a note. Remind yourself, what did you do wrong? And look at your paper. It should look like my page looks like this. I mean, look at all this beautiful math. If your paper is clean as a whistle, then I'm thinking you're guessing, you're getting them wrong, and you just don't care about it. But you know what that means? That means you don't care about your big, beautiful brain. And that's just not fair to you. You should care about this, because this is what makes you better. This makes your brain work faster. It makes it stronger. That would be like saying, you know, I don't care about taking my medicine to cure a disease. You want to do that. You want to do things that are good for you. So make sure that you're doing this practice, and make sure that you're getting some sunlight and some fresh air and some exercise, and do some art, because that's really good for you. All right, guys, I'll see you tomorrow. I love you. Bye.